to draw yourself this beautiful circle, whatever you have. We're going to talk about all the pieces of arcs and chords that are related to this thing. Okay, so give yourself a circle and give yourself a center on that circle. And we'll call this with a P right there. So how would you describe what that circle is called? What's the name of that circle, everybody? Circle P. Yeah, circle P. Circle P. Give yourself a radius from P all the way up. We'll call that point A. Give yourself another radius all the way up. We'll call that B. Okay, and we've created a few things here that we need to talk about. The space in between here is called the central angle. Yeah. Okay. And this space that's denoted on the outside here that I'm highlighting here in between A and B, that's known as what's called an arc. So that's called arc AB. In this case, they call that the minor arc. And the way that we represent an arc is from A to B with like a rainbow over it. So that's arc AB. Arc AB. And then there's this leftover space over here. We give ourselves another point over here called C. We have this other space outside here. And this one would be called the major arc. And we would call that arc ACB. So arc ACB. And notice that we go in order, right? We go from A to C to B. So that would be major arc ACB. You could also say BCA also. Just got to have that point in there. To describe. Yeah. How do I make it bigger? What do you mean? If you had a circle, another special case here, if you had a circle, and you have the diameter, yeah, what you get then is the arc that's created, that's called a semicircle. Alright, that's all pretty straightforward, so we just have some terminology there. We have the minor arc, the central angle, and the major arc, and we know how to represent them now. Okay, so let's measure some angles. Show you how to measure some angles. So give yourself a circle, give yourself a center, give yourself a diameter, and we'll call that EHF. And then we'll call this G over here. So if I have a 60-degree central angle for angle GHF, then that corresponds to this arc measure here. So the measure of arc GF is equal to the central angle of 60 degrees. So the arc measure is the same thing as the central angle as long as that central angle is actually in the center of that circle. So the measure of GCF would be 60 degrees. And the measure of HF would be what, everybody? What would be the measure of HF? That would be 180 degrees. Totally right. So that's how we measure arcs. Okay, we measure arcs based on its central angle. What do you guys think so far? Pretty straightforward? Yeah. Pretty easy. That would have to be 180 degrees. Okay, so you feeling pretty good about that part? Yeah? Okay, I need you to bust out your toolkits here. Okay? Okay, there are 4 things we're going to put on our tool. Here is the next one. This one's called Theorem 10.2. Or, sorry, it's from section 10.2. It's called Theorem 10.4. The other one is called the arc addition postulate. Okay, this one has something to do with a relationship between the chords of a circle and the arcs of a circle. The chords of a circle and the arcs of a circle. So, what it says is that it says arc AB, which is the blue one that I have highlighted for you, is congruent to arc BC if and only if, that's the IFF part, it says if and only if you know that AB is congruent to BC. So I've highlighted all the circle parts, the arc parts that you need. So only if those chords are congruent can you then say that the arcs are congruent and vice versa. Only if the... Okay, this one's a little strange here. What we have here is we have a diameter all the way across the circle. We're calling this... we have a diameter and we have a chord from D to F. And then we have line segments in between, right? So DE and EF are your line segments. And those are if those are congruent, then the arcs are also congruent. So it has to be a perpendicular bisector from D to F. If you've got a perpendicular bisector, that means it's going to bisect DE and EF, and it's also going to bisect the chords. The arcs on the outside. So the chords and the arcs are bisected. So last one here. Here we go. This is an if-then statement for the last one, section 10.2, theorem 10.6. It says if ML is a perpendicular bisector, then JK, the other chord, has to be a diameter. So if chord ML is a perpendicular bisector, then JK, the other chord, has to be the diameter. So if it's perpendicular, which means 90 degrees, and it bisects, means each piece is the same, then the other chord has to be... Alright, we're doing GEF. Cast your vote for GEF. Hey. Yeah. Remember, we need to go, we want GEF, so we want to go from G to E all the way to F. So it looks like 40 plus 80 plus 110. How much is that? That would be 230 degrees. Yeah, very good. Okay, and number 3, here we go. What would GF have to be? Cast your vote for GF. What would GF have to be? 30. So that one is definitely C for that one. Okay, here's next example here. All right. It says find the measure of the blue arcs. Are they congruent? Find the measure of the blue arcs. Are they congruent? So 45 no, 45 yes, 90. All right. Okay, that one's pretty straightforward. Let's see here. We got 100% on that one. Let's do this one. Find the measure of the blue arcs. Are they congruent? All right, you got 30 seconds. 30 seconds. Find the measure of the blue arcs. Are they congruent? When things are too simple?
Yeah, because then you're like, is it just like...
Well, obviously it must be this. Right. All right, we got 7 seconds left. Cast your vote. Who's number 9? Is there a number 9 out there? You waiting? Is that you, Abby? Oh, okay.
I had to get it.
Oh, all right. 25 people said A. 6 people said B. Okay, nobody said C. All right. How can you tell if the arcs are congruent? How can you tell if the arcs are congruent?
Is there like an angle postulate or is it one side?
They have to have the same what?
Measure angle.
Yeah, they have to have the same central angle. Right? The measure of each of those arcs is the same. So this is definitely yes. So take that knowledge and apply it to this one. Ooh. All right. All right. What do you think? Find the measure of the blue arcs. Are they congruent? Ooh. What do you think about this one?
The arc itself or the angle?
The measure of the arc. Ooh, we got some controversy over this one. Find the measure of AD using 10.4 in your toolkit.
On your toolkit.
2x equals x plus 48 something.
It was 19.
Those two are equal.
Oh, I'm writing it down. Oh my god, bro.
Did you click it?
I was the first one.
I'm not concerned with time.
I got my word.
Yep. Let me see. I'm excited. Whoa! How many people voted? Oh, only 18 people voted. What's wrong?
I got it right.
All right. What's theorem 10.4 say? What does it say? Sum it up. Sum it up. If the chords are congruent, then the what? And the arcs are congruent. So you can set 2x equals x plus 40, and find the measure of 80 has to be 40. So everybody got that one right. Nice job. And I think that's the last one. Everyone that voted got that right. Yeah, we are done there. Okay, good. Okay, here's what I'd like you to do. Next on our agenda here, we're going to do our in-class assignment. So I would like the two of you to turn around and make a family. Like the two of you